Good evening, dear students and viewers. Today in this class, we are going to solve one problem that is shown here. Find the moment of inertia of area of T section shown below about x prime axis passing through its centroid. So for this section, that is a T section, that is the centroid of the whole or the entire area, and this is the x-axis that is parallel to one of the edges, that is either this edge or this edge. We have to determine the moment of inertia of area or area moment of inertia about this axis passing through the centroid. All dimensions shown here are in millimeter. Okay, so the dimensions that are shown here, you can see 40 millimeter wide, 100 millimeter long, and then it is 150 millimeter long, and this is also 40 millimeter wide. Okay, now for this we have to first determine the centroidal position. That means from this edge what is the distance of the centroid, because we do not know that. So first we will do that determination of the centroidal coordinate. That is the first job to do. Let us determine the position of the centroid about the x axis passing through the bottommost edge. So this is one reference. From that we will first determine what is the position of C. Now from the symmetry we know that the centroid will be on this line. So along the y-axis what is the x position, that is known, but what is the y distance, that is not known. That means the centroid will be definitely on the middle of this, that means on the center line, but what is the y distance of that we do not know. So that distance y c prime we will determine that, or better to say y prime c, that we will determine. Okay, so for that we will basically use the composite area. That means here we will take the whole area as composed of two regular areas. Regular areas means like rectangle or circle or semicircle or triangle. These are considered as regular areas, and for which we readily know the centroid. Like for this rectangle, for that means the rectangular area, the centroid is the position where the two diagonal intersects, like that. So we will consider two regular areas. That means we will consider this whole area to be composed of two regular areas. Therefore what we will do, we will draw one line here so that it will make it two rectangles, this one, another one. So here I have shown that. That means I have drawn a line through this point, and therefore this can be considered as a rectangle of width 150 and 150 by 40. This is A2 and this is A1. A1 is, that is 40 mm by 100 mm. So two regular areas A1 and A2 are considered, and for these two we know the centroids. That means individually for this rectangle we know the centroid, that is denoted here as C1, and for this rectangle the centroid is C2. We know this. That means that is the midpoint of both the width and the length. So that is known. Now therefore by using the composite area we will use the centroid of the entire area. So therefore what we will do, here we are actually marking some things. Say for example this is x-axis, xx. Now through this centroid I mark one axis, that is x1 prime, x1 prime. Through this centroid I mark another axis, that is x2 prime, x2 prime. That means area 1 and the centroid of that is C1, and the axis that is passing through that is x1 prime, x1 prime. This is area 2, A2. Then the centroid is C2, and the axis, that is centroidal x-axis, that is passing through that is x2 prime, x2 prime. Okay, x2 prime, x2 prime. Next, what? The entire, for the entire area, the centroid is at C. I do not know that, yet I do not know it, and the axis that is passing through it is x prime, x prime, just like here. So along with these two, I have considered two more centroids for the regular rectangles. One is here, another is here. These two are known, that means this is known, but this is not yet known. We will determine this using the centroid of the known rectangles. Okay, so what is yc1? Yc1 means distance of this centroid from this line. So that is known because this area is regular, so I know it. That means where is c1, I know. So yc1, I name it. I know it. Yc1 is equal to the whole length, whole height, 100 divided by, this is 100, so this is 100 divided by 2, that means 50. So that is 50 mm. Similarly, I know what is y2, yc2. What is that? Yc2 means this is the centroid c2 of area a2, and therefore from this axis the distance is this plus half of this, that means it is 40, therefore half of that is 20. So it is 20 plus 100, that is distance of the centroid of the area a2 along the y direction, from the x-axis, x-axis, that is 100 plus 40 by 2, that is 120 mm. Okay, I guess it is clear. So yc1 and yc2, yc1 is the distance of c1 from this axis, and yc2 is the distance of c2 from this axis. So these two we know. Next, what we do? We determine the areas. So area means basically a1 and a2. So this is 40 and this is 100, therefore it is 40 multiplied by 100, it is 4000 millimeter square. Unit is given in millimeter. A2, so that is 150, and this is 40, so the product of these two, 150 multiplied by 40 millimeter square, that is 6000 millimeter square. Okay, so these two are known. Now what we will do, we will use the definition of centroid. So yc prime is the centroidal coordinate of the whole area, that is the T section, that is area a1 plus a2, measured from the x axis from the definition. Okay, that means from the x axis, that means from this axis yc prime. So from this axis, you can see, from this axis, that is yc prime, that is the centroid of the entire area measured from the x axis, from the axis passing through the edge or aligned with the edge. Okay, so that is basically the yc prime. Now from definition we can write that yc prime is equal to summation of yci ai divided by summation ai. What is yci? Yci, you can see, yci means yc1 for area 1, yc1, and yc2 for area 2. So this is yci, means I is equal to 1 to 2. Two areas are there, two regular areas are there, therefore I will vary from 1 to 2, therefore it is yci ai. So yci multiplied by the entire this first area, and then plus summed with yc2 a2, that means yc2 a2. So that is the sum of the product of yc and area. So individual area multiplied by its y coordinate of the centroid plus this area multiplied by its y coordinate, that means centroidal y coordinate from this axis. So that is the numerator divided by the entire area a1 plus a2, that is sum of ai varying from 1 to 2. Okay, and we have just replaced these values because we know a1 a2 and yc1 yc2. We can directly replace these here and we can get the values. You can see the value that is coming to be 92 millimeter. So that is the first job, and as we know that xc will be 0 because it is the center line and this is a symmetrical object about this line, that means midline or the center line. Therefore the distance of this point from this line is 0 definitely, because this is situated at the at this line. Okay, so I guess it is clear. Therefore, the first job is done. That means determination of the centroidal position measured from some reference line. This is the next. This is a known reference line. From this, I can measure. Therefore, the position of the centroid, that is coming to be 92 millimeter. Now you can see that this is 100 and this is 92. Therefore, it is 92 from this, and therefore this will be 100 minus 92. That is 8 millimeter. Okay. Next, what we will do, we will now basically go for determination of the moment of inertia. So next, what we will do, we will basically determine, or that means using we will determine the moment of inertia using the parallel axis theorem. Here we will basically use parallel axis theorem, because for this regular area, you can see, for this regular area the moment of inertia is readily known about its centroidal axis. Now we will determine the moment of inertia of this area about this axis. Therefore, I know the moment of inertia of this area about this axis, that means about its centroidal axis. Now I will transfer the moment of inertia to this point. So that is done by parallel axis theorem. Similarly, for A2, I know the moment of inertia of this about this axis, that is centroidal axis, about passing through the C, passing through point C. Now what I will do, I will transfer that to point, it is C2. So I know the moment of inertia of this area about this axis passing through C2. I will transfer it to point C. So from this I will transfer it to C, from this I will transfer it to C using the well-known parallel axis theorem. Okay. For that I will just go for recapitulation. That means if I have a rectangular area, what is the moment of inertia about its centroidal axis, say x prime x prime? What is that? B h cube by 12. So this is B, that is the width, and the height is across that axis, so that is h. So it is B h cube by 12. So B h cube by 12, that is the moment of inertia about the centroidal axis parallel to B. Okay, that means this axis is parallel to B, that is BH cube by 12. Similarly, for the centroidal y axis, that is parallel to H, that is equal to B cube H by 12 or H B cube by 12. Okay, so the area is here B into H. Okay, next we will use the parallel axis theorem. So according to the parallel axis theorem, Ixx, that is moment of inertia about any axis which is parallel to the centroidal axis, that is centroidal axis is x prime x prime, any axis xx which is parallel to the centroidal axis, this can be anywhere. Like for example, this xx can be anywhere. That means it can be here, it can be here, it can be here, anywhere, but only constraint is that that axis should be parallel to this. So on the right hand side you have this which is passing through the centroid, and on the left hand side you have any axis which is parallel to x prime x prime. Only thing is that, and that is this equal to this plus this, where y is the distance between the two axes, and area A is the area of the rectangle, or in that case area of any geometry for that matter. Here it is rectangle. Okay, now these I have mentioned that these two are the axis where x prime is the centroidal axis and xx is any axis, and the distance between them is y, that is mentioned. Okay, Next, I have just written, and next what we have done is I have given two such names of the axis. One is x1 prime x1 prime passing through c1, and another is x2 prime that is passing through c2. Now what I will do, I will use the parallel axis theorem to transfer the moment of inertia of this from this point to this point, because this point is known. I want to calculate for this point, so I will transfer using the parallel axis theorem using this formula. Okay, so here x1 prime is known, so because that is this one, that is the moment of inertia about the central axis, I will calculate it first. So that means what, this is the moment of inertia of area A1, moment of or area moment of inertia of area A1 about its centroidal x-axis, that is passing through point C1, passing through C1. So that is 1 by 12, that is bh cube by 12, b h cube by 12, that is b here, b means 40, h means 100, so b h cube by 12, that I have calculated, millimeter to the power 4, because the unit of moment of inertia or area moment of inertia is millimeter to the power 4, because you see that it is y square dA, so unit of y is millimeter, so y square means millimeter square, again area is millimeter square, so millimeter to the power 4, that will be the unit of area moment of inertia, that you have to remember. Next, what, in the same way I have determined what is the moment of inertia of area, that is area moment of inertia of area 2, that is A2 about its centroidal x-axis. That means what, about the centroidal y-axis, centroidal x-axis passing through C, that I have determined. Okay, so that is 1 by 12 150 into 40 cube, so 150 is the length and 40 is the width, so bh cube by 12, that I have done, millimeter to the power 4. Next, what I have done, so therefore I know what is the moment of inertia of the area about its centroidal x-axis. I know the moment of inertia of this area about its centroidal x-axis. Now I will transfer using the moment of parallel axis theorem. So I have done that. That means that about that axis it will be sum of this plus this. Now please note that what is this, y c prime minus yc1. What is yc prime? Yc prime is this distance. Therefore what is this distance? Because for this area A1 I have to transfer from this to this. Therefore what is this distance? This distance will be equal to this distance minus this distance. What is this distance? This distance is yc prime. And what is this distance? This distance is yc1. Therefore I have written here as yc prime minus yc1. What is that? You see again, yc prime minus yc1, yc prime minus yc1, therefore it becomes this distance. Again I for this, that means I have just used this equation here, so that is this plus this squared multiplied by a1, area 1. Okay, next what, it is for this area, so it will be I x2 that I have already calculated, plus yc2 minus yc prime. Why? Because yc2 is this distance, that from this point I have to transfer it here. Therefore what is this distance? This distance is this minus this, so whole length minus this length, so this length is yc2 and this length is yc prime, that means from this it is yc prime. Therefore it will be equal to yc2 yc2 minus yc prime. Clear, I guess? So it is yc2 prime, yc2 minus yc prime whole square, because it is square multiplied by a2. Okay, so therefore you just replace the values, because all the values you have already calculated. You just replace the value and you will get the final value to be 15893333.33 will come, but we will ignore this because this is not significant digit in this case, therefore we will ignore that, and it will be simply after that decimal we will ignore this. So 15893333 millimeter to the power 4 will come as the result. So this is done using the parallel axis theorem. This same thing you can do using the definition. That means from the first principle also you can do it. So let us see how to do that. For determining that, the determination of the centroidal axis or centroidal coordinate is necessary. So for the determination of the moment of inertia, from the definition we require this part. So that is common. Next, what we do, we use the definition. Now as we know that for definition we will basically integrate. So here what I do is solution directly from the definition. That means without the application of parallel axis theorem. So what I do, I take a rectangular strip here. So that is parallel to the axis for which I want to calculate the moment of inertia. I want to calculate the moment of inertia about that axis. Therefore, that means centroidal x-axis. Therefore, this is parallel to that axis I have taken. Now, from this axis, that is x prime, the y distance is denoted as a variable, that is y prime, and the width of this strip, that is dy prime. So at a distance y prime, the thickness or the width of the strip is dy prime. Okay, and this length is b, this b. Okay, so the area will be, the elemental area of the strip will be b dy prime. Okay, now we have to see, this is from the now we see that this b will vary, we will see, because from this point to this point b is something, and from this point to this point b will be something else. This is discontinuous. Okay, so it will be same for this part, and again for this part it will be something else which is again different. So from the definition of the area moment of inertia about the centroidal x-axis passing through point C, now by this time we know what is the distance because we have already calculated it earlier here. So that part is common, I told. So that we have to do first. Then we will go for using the definition. Remember that. Okay. So here one thing we have to follow, that this is the definition. So I x prime is equal to y prime square dA over the whole area. So y prime square means y prime square of this distance multiplied by area integrated over the whole area. Again I told that this is the differential area. So that is b dy prime, elemental area parallel to the x prime axis. Here b is different for different zones. Zones means this one zone, another zone. B is different. So b is 40 millimeter for y prime is equal to minus 92 to plus 8 mm. Why? Because for this zone b is this much, so 40 mm, this is 40 mm, and that is basically this is 40 mm for y is equal to minus 92, because y is measured from this axis, that means from point C. Therefore this one will be in the negative direction, that means from this point it will be negative and it will be positive. So in this direction it will be positive and in this direction it will be negative. Therefore minus 92, because it is 92 mm, therefore in this direction it will be minus 92 to plus 8, because this much is 8, total it is 100, therefore minus 92 to plus 8 it will be 100. You can understand, this is minus 92 and this is 8, so total it is 100. Okay, 8 is measured from this part, and b is equal to 150 mm for B is equal to 150 mm. For y is equal to plus 8, that means measured from this point, because from this point it is plus 8 and after that it is again 40. So plus 8 plus 40, that is 48. That means this is 40. So 8 to 48 it will be 40 mm, right? So that is 150. I guess it is clear. Next what? Therefore we can write, now what we will write, we will just split this. So I x prime is equal to minus 92 to plus 48. That means entire zone I take first. So this is minus 92. That means y coordinate, y distance is minus 92 from this and plus 48 here. So minus 92 to plus 48, up to this it is basically written here that for the entire zone minus 92 to plus 48 y prime square into dA. dA is equal to b dy. So that I have written y prime square b dy. Now what I have done, I have splitted it according to the variation of b. So minus 92 to plus 8 y prime square into b dy. Now b dy, b means 40 into dy prime. That I have just replaced value of b, because for this zone minus 92 to plus 8, b is constant. This is constant. Again from this point to this point b is constant but different value. So I have just splitted the integral. So here minus 92 to 48 is splitted into minus 92 to 8 and 8 to plus 48. Okay. So for this zone b is 40 and for this zone b is basically 150. Okay. So same thing I have done, just replace b. Now since b is constant, b is taken out of the integral. So minus 92 to plus 8 and plus 8 to plus 48. Same thing. For this I have just done the integration y cube by 3, y prime cube by 3 and y prime cube by 3. The ranges are different. I have just replaced the values here, minus here, so it will be positive. And that means it will be 8 cube plus 92 cube and it is 48 cube minus 8 cube. Again you just replace you just calculate it and you will get the same value, that is 15893333 millimeter to the power 4. I have just discarded the fractional part because of non significant digits. Okay, so you see that you can use any methods, either using the parallel axis theorem, using the composite area, you will get this value, or you can use the definition and integrate it and you can get the same value. Okay, whichever is easier for you, you can do it. For I think for rectangular areas, both are I think convenient. Only thing is that first you have to determine the coordinate of the centroid. After that, I think both methods are convenient to do. Thank you.